Can't hear that word. Okay. Okay. Can't do copyrighted music. So, can't do copyrighted music. Sadness. Hi, Eddie. Welcome. Gotta move my stuff. Feels like it's not centered. Okay. Wait till other people join before I go on, so I can let people know that they can. Which is easier for notes? Do you want a Word document or a PDF? I figure a Word document would be easier to fill in. I'm not sure. Okay, so at the end of the song, I'll start. Let's standard notes. Oh, is it easier to have the notes as a Word document or a PDF? I sent both. If you look slightly blurry, huh? Just three. Welcome, Daniel. I'm figuring you guys will join as we go. So, 3 people. Okay. There's some Woo. This will be a shorter lesson today than usual. So hopefully we'll get through this within the hour. So if you have any questions, feel free to ask. So the question is it easier for me to give you a PDF or a Word document, or do you prefer just do not use either of them? If you don't use either of them, it'll save me time, but I figure it's useful. Okay, you use PDF. Same thing, similar, do you use PDF or document? Okay. Okay, we're going to talk about polar coordinates. So, okay, you use lists. Okay, well, nevertheless. Okay, polar coordinate system is going to be the one where it's defined by r and then theta. So it's defined by some radius, and then some angle. Okay, that's what we're going to learn. Okay, there's more definition to it, but right now we're just going to look at it's the basics. Okay, so coordinate system it has a fixed point. It has a fixed. This is a fixed point O, which is also which is also the origin. Okay, so we need to know that there's fixed pole, which is our origin. Okay, kind of think of a pole like you stick a needle through it, and you can spin everything else, but that needle, that point won't move. Okay, such as the North Pole and South Pole. Now, a polar axis is the initial ray, and it's kind of, I'll show a picture here in a moment. So the initial ray from our O, okay, from O, okay? Sorry, real quick, gotta get our, okay. So I'm going to, hi Henry, I'm going to just define each of these and then I'll show you a drawing of them. Okay, the next one is the polar coordinate, which we kind of just, oh, the polar coordinate system is the plane. Sorry, it's the plane. Polar coordinates is what I already defined. It is r comma theta. And we have two aspects to it. This is why you don't double space. There we go. Makes my life easier. Okay, the first thing is that R equals the directed distance. I'll explain what that means. From O to a point P. Okay? And theta is our directed angle. Okay? Directed angle counterclockwise from polar axis to segment OP. And see if I can do it. An accent? It's an accent. Boom. There we go. Okay, so I'm going to make the drawing down here. Okay, but I'm going to actually make the drawing on my whiteboard. So I'll leave this up. Okay. So if you have any further questions or want me to zoom in, here we go. I zoomed in. Okay. Okay. So we have our point O, our origin, or rather our pole, and we have our polar axis, okay? Now, we choose some point P, which equals, oh sorry, that's out of the picture, some point P, which equals r theta, okay? Now, r is going to be this directed distance. Okay, it's going to be this direction. Okay, theta is the rotation this way, and theta is our directed angle. Okay, so we have our polar axis. We rotate theta amount and r distance away from our pole to get this point. Okay? Now, we are going to have a lovely graph to help us out so that this won't be as hard. But we are going to be dealing with polar graphs. Okay? So again, r is our directed distance, theta is our directed angle. So if theta is positive, we're going counterclockwise. If theta is negative, we're going clockwise. Okay? If r is positive, we're going up. If it's negative, we're going either left or down. Okay, so it changes how our angle looks. Okay, let's do some problems graphing this. Okay, zoom out a little bit. Okay, we have several graphs, but you can graph to one of those pictures. Okay. So I'm just going to make it easier for myself. I'm going to be doing it here. 2, 3, 4. 1, 2, 3, 4. Okay. And then the angles. Anyway, I'll cover the angles later. Okay. We get two, actually, you know what? I can draw it on document. That makes so much more sense. Okay. Easy to wish this works. Okay. So I'm going to graph this one. Now, if you notice, it's pi over 3, which means we rotate pi over 3, and we're 2 away. So 1 is this the center, 2 is here. So I'm going to insert. Okay, not there. I'm going to insert a shape. Okay, and I'm going to draw it from the center. Sorry, my apologies. Okay, center, and it's going to go 2 up. Okay, now I'm going to make this darker so you can see it. So, this is our angle right here. Sorry, let's move this proper. Okay. Yeah, I think that's correct. Yeah. Okay, do you see how this black, let's zoom in a little bit. Okay, do you see how this black area is 2 radiuses and it's pi over 3 angle? Okay, angle pi over 3. Okay, so that's this first one right here. Okay, so we did this one. So what about 3 negative pi over 6? So 3 distance, negative pi over 6 would be right here. So if we were to insert a shape, let's make it an arrow. Yeah, I'll make it an arrow. Okay, so it's pi over 3, pi over 6, and it's 3. Okay. Okay, I'll delete this for a second, or let's remove this off. Okay, so this is negative pi over 6, and it's, sorry about that, and it's exactly 3 distance away. Okay, hi Catherine. Okay, so we're covering this. You might want to go back and start over the video so you're not confused. Okay, so negative pi over 6, 3 distance. Now, try this one. 3 and 11 pi over 6. 3 and 11 pi over 6. What would that look like? Okay. Which quadrant would that be in? Quadrant 1, 2, 3, or 4? Which quadrant is the same? Which quadrant? quadrant 1, 2, 3, or 4. And the answer is quadrant 4. So 3 distance, and 11 pi over 6. Okay? And the last one, 2 5 pi over 6. 5 pi over 6 is right over here. And 2 is 1, 2. 2 radiuses. So insert a shape. We go 1, 2. 5 pi over 6. Let's make this blue. Actually, no, that blends in pretty blue. No, you don't have to do the arrow. So if I was to change this, I could just make it here. If I was to change this, now to insert shape, I could do a line. And just, there we go. Okay? You don't have to put the arrow. Okay? So that's graphing right there. Whoa! Zoomed out so far, we went to the beginning. Okay? Okay, I want to make a note. Important note. What's the note? Well, every angle is technically written like this. R comma theta, so far we know this, R comma theta. This equals R comma theta plus or minus 2n pi. Okay? So all our angles can be written either that way, where the angle changes, or it can be written R comma theta R comma theta will equal negative R comma theta plus or minus 2n plus 1 pi. Okay? So basically we have a lot of different possibilities for how to write our angle. Okay? We have a lot of possibilities for how to write our angle. Okay? Zooming in. Okay? So, there are multiple possibilities. We're going to try some problems where we need to plot it, and then we need to find the additional representation. 2 additional representations. So, I want you guys to graph this one, and then I'm going to talk about how to find 2 additional representations. Okay? So actually you could graph all 3 of them. Now, if you don't have this kind of graph on your paper, you can just approximate the angle. certified shape. So it's 3 away. Negative 3 over 4 is going to give us, actually, you know what? Let's play what's on and then we don't have the circle thing. You don't need to make. You don't need to make the circles. Okay, that's enough time for one. Okay, so for this first one, and nightmare. Let's just delete it. Insert, I'm going to insert shape, make a line. Okay, so it's negative 3 over 4, which is down here, and it's 3 distance. So we go 3 distance, and negative 3 over 4. Make sure our graph is actually accurate to the Here we go. And we just darken it. Okay? So that's our graph. Now if you were wondering how to do it without this kind of graph, let's show you that. Okay, so we have this. Now the way I would do it, 1, 2, 3, 1, 2, 3. And so this is going to be about a 45-degree angle. Should be about right here. Okay. Sorry about that. So it'll be here and here. Okay. So this would be our 3 comma negative 3 pi over 4. Actually, no, wait. My apologies. That's 1/4. Be over here. See, this is the problem. When you don't think about how far you're actually moving, get right here. About 45-degree angle. Okay, there we go. So it's 3 comma negative 3 pi over 4. Now, we need, yeah, it's third quadrant, my apologies. Okay, now we need to figure out what other equations we can get with this. Sorry about that. Let's look at this. Okay. Now we have 2 possibilities. We can either change our r or change our theta. We change our theta, so we get our 3 pi over 4, and if we add 2 pi to this, we get 3. This becomes 8 over pi over 4, which if you add them becomes 5 pi over 4. So this is one of them. Now what would be our next possibility? Our next possibility would be if you take the r, so we get negative 3, and we're going to do theta, negative 3 pi over 4. but we're going to add 2n pi. So we're just going to add pi. Okay? Which if you add pi, will give us negative 3 pi over 4. Okay? So our two answers are 3 comma 5 pi over 4 and negative 3 pi over 4. Now, is there one more solution? Yes, you bet. But I'll leave that one out so you can figure it out. Okay? So those are our ways of solving this. Now, you guys let's try one more question. Okay? From the note. So let's try the second one right here. Because it already has the negative theta, okay? I mean the negative theta. Oh, that's a good question. Sorry. Let me address that real quick. Okay, before we can move on, why did I add pi here? Remember the formula I gave you. Negative r, comma, theta, plus or minus 2n plus 1 pi. Well, n here, I substitute n equals 0 in right here. Okay? I substituted n in as 0 right there. Okay? So try the second one and try to find out two additional points. Okay? Okay, so try this one right here. And let me know what two additional points you get. Okay? Okay, what did you guys get for the second one? Now, some of you might be sitting there being like, I didn't do anything. Well, here we go. So the angle, the polar coordinate is negative 2, comma, 2 pi over 3. Now, negative 2, comma, 2 pi over 3 is going to give us that beautiful spot right here. Okay? Oh, sorry. Need to double check my work right here. Oh, it was wrong. Okay. Sorry. Okay. So if you take the angle, my apologies, take the angle 2 pi over 3, that would give you over here. Okay. If you had the angle, it'd be like 2 pi over 3 is roughly like right here. Okay, which roughly translates maybe, sorry, 2 pi over 3 is roughly over here, which would translate to roughly right here. Now the negative 2 gets you right here. Okay, so you don't do the negative 2 first, you do the angle first, okay? Angle comes first. Then, if we want to translate this, so we have our negative 2, 2 pi over 3, and then we're going to minus 2 pi. Now the reason is because our angle needs to be between negative 2 pi and 2 pi. So if we added 2 pi, we would go way too high. Okay? So then we get negative 2, comma, this is just 6 pi over 3, which gives us negative 4 pi over 3. Okay, so negative 2 comma negative 4 pi over 3. And then we get one more option by making this r negative. So if we make it positive, we get 2. We get 2 pi over 3. We have two choices, meaning either add pi or minus pi. Okay? Add pi or minus pi. In this case, I'm just going to add pi. Why not? So we add pi to this, we get 2, and then this is just 3 pi over 3, which is 5 pi over 3. Okay? Okay? So, that would be two of our solutions. Okay, let me just show you the last one. A lovely angle with no radius. So how does that work? Well, fortunately, or fortunately for us, you could think either way, it is just going to be, well, let's take a look at it, okay? Sorry, just got to double check my work. Don't want to be giving you some false information. Okay, we have our angle somewhere, but because our radius is 0, we're plotting the point here. So the only thing that's changing is going to be this radius, this angle. So if we add 2 pi to it, 0, negative 7 pi over 6, plus 2 pi, we get 0, comma, and this would just be 5 pi over 6. And if we did 0, 7 pi over 6, plus pi, we would get a lovely 0, and this would become negative pi over 6. Okay? So basically the only thing's changing is our angle. We'll get that plotted point right in the middle. Okay? Plotted point right in the middle. Okay? Let's look at, now let's continue on. Coordinate conversions. Okay? Now coordinate conversions, we've got to remember something. We've got to remember, let's load that up. If you ever need me to stop or go back, please let me know. I will keep going otherwise. Just assume you guys are watching. Okay, we need to remember some stuff. First thing we need to remember is that tangent of theta is going to equal y divided by x, and that cosine theta is going to equal x divided by r, okay? And then that sine of theta is going to equal y divided by r, okay? So tangent, x divided by r, cosine theta, or x over, I can actually just make this font bigger. That'll help. Okay. For some reason the equal signs, I can't see the equal signs. Okay, there we go. Okay, so remember this. Now, the relation, coordinate conversion, the relationship between polar coordinates, and that's going to be our r comma theta, and rectangular coordinates, it's going to be our x comma y, is as follows, okay? Now we need to look at our conversions, okay? So the relationship between polar coordinates and rectangular coordinates is as follows. So polar to rectangular, sorry, didn't apparently create a, okay, let's turn this to 1, so we actually can write this. Okay, first one we need to see, polar to rectangular is x equals r cosine theta. Okay? And then obviously it would make sense to have y equal r sine theta. Okay, if x equals r cosine theta, and if you think about this, it's basically just reworking it to the x by itself. Okay, now rectangular to polar is going to be interesting. We need to use our tangent. Tan theta is going to equal y divided by x. Okay, that's for rectangular to polar, and r squared is going to equal x squared plus y squared. Okay, so polar to rectangular is going to involve cosine and sine. Rectangular to polar is going to involve tangent and then the circle formula. Okay? So really, we're basically halfway done. Hopefully that means we'll be able to finish this pretty quickly. Okay, I'm not going to go through all of these points, but let's do some of these. So this is converting from to rectangular from polar. Okay? So, to rectangular from polar. Let's, I'm going to do the problem so that you can have the formulas up. So that will help you, okay? Okay, so, sorry real quick, let me see. Okay, let's do 2 of these. We'll do the easiest one, obviously. And root 3 pi over 6. Okay, so our conversion. Okay, so first 2 comma pi over 2 comma pi. So x is going to equal r cosine theta, which will equal 2 comma 2 cosine pi. What's cosine of pi? -1. So this would become 2 times -1, which is -2. Y would equal r sine of theta, which equals 2 sine of pi. Sine of pi is 0, so this is just 0. So our point is -2 comma 0. Okay? That's for this one. Okay, this other one, now if you have any questions, please feel free to ask. Always free to ask. This is why we did trig. So maybe if I did trig and then this, that would make sense, but whatever. Okay, r cosine of theta. So we get √3 times cosine of pi over 6. Now, does anyone know what the cosine of pi over 6 is? How is r2? It gives us r right here. R is the radius right here. And this is theta. Okay. So cosine of pi over 6, if we know that, if we remember our rules we need to memorize, cosine of pi over 6 is √3 over 2. So, √3 times √3 over 2 equals x equals 3 over 2. Now y equals r sine of theta. R is √3. Sine of pi over 6 is equal to √3 times 1/2, which gives us √3 over 2. So our answer is 3 over 2, comma, √3 over 2. And that's our point. Okay? Daniel, you don't need to use a unit circle for this because at this point you should have familiarity with where things hit. Now, if you need a unit circle, I don't think it's going to be provided for the test, so I would highly recommend remembering some of the stuff we memorized. Maybe next time. Yeah, that would make sense. Okay. Okay, I'll do one more question. Since there's, oh no, there's 4. You guys can do this one. Is cosine x. Essentially, it's related. Okay, so the question I want you to do, I'm not going to solve it for you. You're going to give the conversion of 2 comma 3 pi over 4. That's way out of the picture. Why is that? Oh, no, it's not. Okay. Okay. So, give the conversion for that polar coordinate. Okay? Give you a minute. Write it in chat so that I know you know it. Yeah, let's do this one. Okay, what'd you get? What's the answer? So, x are cosine of theta. So you get 2 cosine of 3 pi over 4, which equals something. And y equals r sine of theta, 2 sine of 3 pi over 4, which equals something. So 3 pi over 4 is going to be in quadrant 2. So this is going to be a negative. So we're going to get 2 times negative 2 root 2 over 2 and positive 2 times root 2 over 2. So our answer is going to be negative root 2, comma, root 2. And that would be our answer. Now if you were wondering how to type it in the chat, that's a great question, which I won't answer. Feels bad, man. Okay, rectangular to polar. Basically, the reverse of what we've just been doing. Reverse of what we've just been doing. So, we're going to do rectangular to polar. So, let's do negative 1 comma 1. And I'll do 0 comma 2. I'll leave 2 questions for you guys, so if you want to practice, you may. Okay, so we need to use tangent theta equals y over x, and we need to use r squared equals x squared plus y squared. So this is going to give us theta, and this is going to give us r. Okay? So, we get tan theta equals 1 divided by negative 1. So, remember, we have arctan. I'm going to try to finish in the next 9 minutes. Okay, tan inverse of negative 1. And r squared equals 1 plus 1. So r squared equals 2. R equals root 2. What's the tan inverse of negative 1? Well, you have to make sure you're in, I'm in radians. So, tan inverse of negative 1 will give us negative 1 over 4 pi. So our answer is root 2 negative pi over 4. And is this consistent with what the book says? It technically says 3 over 4. This could be 3 over 4. Pi over 4, negative pi over 4, or 3 pi over 4. So this would be 3 pi over 4. Yeah. Okay. And then this one, we're going to get tan theta equals 2 over 0, which is undefined. Def, so then theta has to definitely be pi over 2. Okay, reason is because pi over 2, the x is 0. It should be, hold on, it should fit the quadrant. So what quadrant? This is quadrant 4. And this is going to be quadrant 1. Quadrant 2. So you need to fit it into the right quadrant, okay? You need to fit it into the correct quadrant. So this, for example, right here is in quadrant, is on the y-axis, positive, so then it's going to fit this angle. Okay, then we have r squared equals x squared plus y squared. So r squared equals 0 plus 4. R squared equals 4. So r equals 2. So our answer is 2 comma pi over 2. And that would be our answer. Okay? What if you get tangent is that? Make sure it's in the right quadrant. That's all that's important, okay? The angle could be a decimal. Although, which one did you do it for? Which question did you get negative 1/2? Anyway, if you do it in the right quadrant, that's all that matters, okay? Okay, how to not get a decimal. I'm sorry, sometimes I can't avoid a decimal. Hopefully, we don't have too many questions that have decimals. Okay, equation conversion, this is the last part. 5 minutes, we should be done with this 5 minutes. Actually, it might take longer than 5 minutes, I apologize. We did start a little bit late. Okay, so remember, our x and y can convert, so y equals r sine theta, and x equals r cosine theta. Okay, so I'm just going to plug those in. So we get r sine of theta equals r cosine of theta squared. So we get r sine of theta equals r squared cosine squared theta. Well, I'm going to divide both sides by r. So we get sine theta equals r cosine squared theta. We divide both sides by cosine squared theta because I want the r by itself. Squared theta. Okay, and then this squared can be separated. So we can actually write this as sine theta over cosine theta, because the bottom is a squared, so times 1 over cosine theta equals r. Okay, sine over cosine is tangent theta, and 1 over cosine is secant theta equals r. Or you can rewrite this as r equals secant theta tangent theta. Okay, does it matter order? Not really. It doesn't matter the order. Okay, doesn't really matter the order. So I'm going to try out some of these questions. I'm going to do these two. I'm going to do the first two. And then there's this x, y equals 16, which you guys can do. I have the utmost confidence in your ability. Okay. What just happened? Oh. Hold on. Okay, there we go. Okay. X plus y, x squared plus y squared equals 9. So what do? We turn this into r cosine. Actually, honestly, this whole thing, sorry. X squared plus y squared equals r squared, right? So then all we get is r squared equals 9, because x squared plus y squared equals r squared. And then we square root both sides, so we get r equals 3. There's our answer. Okay? Simple. You don't have to do all of the work, especially if you remember the right formula. Okay? It's important to remember the right formula. Okay, what about a line? Great question, Daniel. What about a line? Genius level questions right there. So what we're going to do is we're going to plug in, sorry. Can I move it over and then divide? No, because then I'll have it still. Yes, it's you, Daniel, who is asking, how do I do this line? Well, you plug it in, so we get 3r cosine theta minus r sine theta plus 2 equals 0. So we get 3r cosine theta minus r sine theta equals negative 2. I'm just simplifying my work. Okay, factor off the r, 3 cosine theta minus sine theta. I'm wondering if there's actually an easier formula, so we're going to check, because it is always worth checking if there is an easier way of writing this. Oh, no, there is no easier way. So we get this. We want to get the r by itself, so we divide both sides by this. So we get r equals negative 2 over 3 cosine theta minus sine theta. And that's it. Henry, you were absolutely right. Daniel had an excellent question. You know, you gotta love that Daniel asked the right question at the right time. Okay, and then xy equals 16. You can solve it yourself. Okay, turning polar into rectangular. That's the last question. So we're gonna just go. We're gonna cruise through these. Cruise through these. Okay. So we get r equals 2, which is the same thing as r squared equals 4. Okay, r squared is the same thing as x squared plus y squared. So we get x squared plus y squared equals 4. Boom, done, finished. What about theta equals pi over 3? Great question. We also remember that tangent theta, tan theta, equals y over x. We got to remember that. Just a second. Whew. That was a close call. Almost ripped a page. Now, what's the tangent of pi over 3? Tangent of pi over 3 is, the answer is absolutely root 3. So, tangent equals y over x, so y over x equals root 3. Or you can say y equals root 3x. Boom, done it. Okay. Now let's get a harder question because this is too easy. It's too easy. Secant or sine? Secant or sine? Secant or sine? Secant or sine? Let's do secant. Of course, we should do secant. Secant's easier, obviously. Obviously, you can see it because it's so abundantly clear. It's not like I didn't know the answer on the first go. Okay, secant is 1 over cosine theta, and we just multiply both sides by cosine theta. Now, guys, I am joking. It was not clear. It was just, I used the wrong phrase. Okay, which becomes r cosine theta equals 1. R cosine theta is x, so x equals 1. Okay? Now, let's try sine, because, I don't feel like it was that clear. Do one last question, and then we will be done. Do-do-do. Do-do-do. R equals 4 sine theta. What do we do here? Oh. Keep it in radians. Keep in radians. Radians. Let's not go to degrees. Nobody needs degrees. I didn't say that. I don't defend that position. I merely said that as an exaggeration. Okay. Okay, so what do we do here? I'm going to square both sides. Why am I going to square both sides? Because. Is that the best bet? Let me think. I think I should square both sides. I'm going to square both sides. Because r squared equals 16 sine squared theta. Okay, r squared becomes x squared plus y squared. And 16 sine squared theta is the conundrum. So conundrum. Here's the conundrum. Real quick. I think that's 85. Okay. So you see this 16. Actually, yeah. This 16, actually we can just leave in here. We didn't need to square this side. We could just leave it. This 4 sine theta is the same thing as saying r equals 2. So we would have, r equals 4. And then, so we have y equals 4 sine theta. So this is just, is that correct? 1 second. I feel like I'm missing something. And then I'll dismiss you guys from being bogged down by this. I was right about this, so what's wrong about this? Okay. Let me think. That's the problem. Okay. I do know I need to square both sides. So what if I subtracted it? Okay, we're going to try that. So we get r equals 4 sine theta. And subtract 4 sine theta from both sides. It's going to have the same problem. If I square both sides, you get r squared minus 8r sine theta minus or plus 16 sine theta, sine squared theta equals 0. I mean, this is accurate. So then this would be negative 8y. What would this be? You know what? I'm blanking on how to do this one. Oh. What? So it just shifts it? So then this would just be x squared plus y squared minus 8y Huh. What am I running into? What problem am I running into? Okay, people, you guys can be dismissed. I will, if there's a question on the homework, which there shouldn't be, there is a question on the homework that is too difficult. Okay, there is a question like this. I'm just going to take off that question from the homework. So you guys won't have to do 5b. Okay, I'll edit it. So there won't be a 5b. I'll work on solving it, and then you guys will be. So no number 5b on the homework. Okay. Anyway, I'll explain it later on the next section. Okay, so I'll explain how to do these on the next section. Okay, so you guys will be dismissed. Have a wonderful Wednesday. The homework is due next Tuesday morning, so yeah. Bye, guys.